In this video we are going to do some questions based on electric field. Okay, so before we do the questions on electric field, you should understand if I have a charge, let's say Q here, positive Q, then the electric field due to a point charge at a distance r, okay, at let's say this point, let's call this point as A, the electric field due to this charge at point A is E is equal to kq by r square, right? And the electric field is a vector with the r cap direction, which is in this direction. So if this was a negative charge, the electric field will be towards that charge, right? Okay, so this is the electric field due to a point charge. But now if I have many charges, for example, if I have charge q1, if I have another charge q2, another charge q3, right? And because of all these charges, I want to find out the electric field at, let's say, this point P, right? Then this electric field at point P is nothing but the vector summation of all the electric field due to q1, q2 and q3, right? So due to q1, suppose if it is a positive charge, due to q1 the electric field will be like this. Okay, this is your E1 bar. And due to this charge q3, let's say if it is a negative charge, right, then the electric field will be like this. This is E3 bar. Due to q2 charge, suppose this is positive charge, then due to this q2 charge the electric field will be like this, E2 bar. Now the vector summation of all these electric field E1, E2 and E3 bar will give you the net field at that particular point P, right? And the electric field due to this charge will not be affected by the electric field due to this charge. The electric field due to this charge will not be affected by the electric field of this charge. So no charges are interfering with each other's electric field at this point. It is a vector summation. This is a superposition theorem. Okay, now since we have seen these scenarios, these things, not scenarios, these things, we will do some problems based on electric field. Okay, let's look at the problems. Okay, so let's look at the first problem that I am going to see here. Suppose I have a square, okay, I have a square, right, and on the vertices of the squares I have charges like this, q, q and q. Okay, these three vertices I have the charges q, and let's say the distance between these charges is a, that is the length of the square is a, side length of a square is a. Okay, and let's say this is positive charge, this is positive charge, and this is also positive charge. I want to find out the electric field at this particular point. Okay, how will we do that? Right, let's see. First you find the electric field due to this charge. The electric field due to this charge is in this direction, the downwards direction, right? So that will be kq by a square, right? Kq by a square will be the electric field due to this charge, right? The distance between this charge and this point is a, so that is kq by a square. Now due to this charge plus q, the distance between this point and this charge q is a, so the electric field in this direction will be kq by a square, right? Okay, good. Now both of these electric field are same in magnitude but different in direction, right? Okay, but now we don't have only these two charge, we have this third charge as well, right? But we will look at it later. What we will do, we will take a resultant of these two electric field. Now see, both of them are equal in magnitude and the angle between them is 90 degree. So you know, if the angle is 90, then the net field will be E1 square plus E2 square plus 2E1 E2 cos 90 degree, right? But cos 90 is 0, so this will be square root of E1 square plus E2 square. But E1 and E2 are same in magnitude. Suppose this is E1 and this is E2, both of them are same in magnitude, so this will be square root of 2E square, right? So this will be root 2E, and E is nothing but kq by a square. So here the net electric field will be in this direction, root 2 kq by a square. Okay, very good. Now this charge plus q will also have its own electric field at this point, right? Okay, so let's say the distance between this is something like this. Okay, now what will be this distance? This will be a, this is 90 degree, so this is a hypotenuse which is root 2a, right? This is root 2a, the hypotenuse. Now this will be kq by root 2a whole square, root 2a whole square. So now this will be in the same direction as that of this, right? It is along this line, right? And this is also making a 45-degree angle. This is also a 45-degree angle because both of the electric fields are equal. So the resultant will be at an angle 45 degree. Since this is 45 degree and this is also 45 degree, right? Okay. So now this electric field due to this charge is along this direction only. So now this electric field is going to be in the same direction, but I don't know if it is greater or less, we will see. So that will be plus kq by root 2a square. Now the net field will be root 2 kq by a square plus kq by 2a square, right? Okay, so I think this is 1.4 times and this is 0.5, so this is lesser, so this will be lesser. So this is the net electric field and the direction is along this, okay, 45 degree clockwise to the x-axis. Okay, this is the net electric field, right? Let me check if it is visible or not. Yes. Okay, let's look at situation like this. Again, if I take okay, let's take a equilateral triangle. Okay, I have a equilateral triangle and let's say at the vertices there are charges like this. Okay, this is, let's say this is one of the charge is minus. Okay, this is minus, this is plus q, this is minus q, right? Okay, and the side length of this equilateral triangle is a, and I want to find out the electric field at this point, correct? Then how will we do that? Okay, let's look at that. Let's call this point as P. Now again, the electric field due to this minus q charge will be towards itself, right? So this will be one electric field. Let's call it as E. So the magnitude of this E bar vector is kq by a square, right? The magnitude is kq by a square. Now this guy plus q will have the electric field not in this direction but rather in this direction, right? Correct. And now the magnitude will be kq by a square, which is same, right? So here the magnitude will be the same, E. Okay, but this is a different vector, so I will write at E dash bar vector, but the magnitude of both of them is same, right? Now since this is an equilateral triangle, this is angle 60 degree, so this angle will be 120 degree. So the angle between these two vectors is 120 degree. So now how will we find the resultant? We know square root of E1 square plus E2 square plus 2E1 E2 cos of theta is the magnitude of the resultant vector, resultant electric field, right? Now the theta is 120 degree, so now we can write cos of 120, and E, both of these have same magnitude, that is kq by a square, so I will write the magnitude as capital E only. Okay, so let's look at the square root of E square plus E square plus 2E square cos of 120. So cos of 120 can be written as cos of 90 plus 30, right? Okay, so this is square root of 2E square plus 2E square. Now cos of 90 plus 30, what is cos of 90 plus 30? See this 0, this is 90 degree, this is 180 degree, this is 270 degree, right? So this is all sugar, add sugar to coffee, right? So now this is all are positive here, only sign is positive. If I say cos of 90 plus 30, then it is coming in this quadrant, and in this quadrant sign is only positive. So that means this should be minus sine 30. So this should be minus sine 30. This is minus sine 30. Okay, so this will be square root of 2e square minus 2e square. Sine 30 is 1 by 2. So this is going to be again e, right? So the resultant itself is e. The resultant itself is e, that is kq by a square. the resultant value of the electric field is same as one of this magnitude of the two vectors. Remember one thing, whenever you have two vectors of equal magnitude making an angle 120 degree with each other, the resultant will be of same magnitude as either of these two vectors, right? And the resultant will have an angle of 60 degree with one of the vectors, right? Correct? So this will be at a 60 degree, and the value of that electric field will be kq by a square, right? So if you want to find out the value of that angle, you know this formula, right? Tan of alpha, where alpha is that angle, tan of alpha is equal to, suppose the vectors are like this, this is a a bar vector, this is a b bar vector, right? And this is the angle alpha, sorry, this is the angle theta, by the way, the resultant angle I am saying, the angle of the resultant with a bar vector is alpha, then this value tan alpha is equal to b sine theta, where theta is the angle between the two vectors a bar and b bar, this is whole angle is theta, and the resultant makes angle alpha with the one of the vector. So tan alpha will be b sine theta upon a plus b cos theta, right? Okay, correct. Since both of them are equal, obviously the resultant will be the bisector of that. Now if you put angle theta equal to 120 and b value as e, then you will get the angle alpha to be 60 degree. Okay, you can try that. Okay, now let's look at the next question. Let's look at the next question. This was asked in JEE Mains 2024. We have two charges. Okay, one is q and another is 3q, right? There are two charges q and 3q. They are separated by a distance r in the air. At a distance x from the charge q, the electric field, the resultant electric field is 0. The value of x is, okay, the value of x from this point charge q, at this value the electric field is 0. So we have to find out the value. So the options are 1 plus root 3 by r, and this is r into 1 plus root 3, this is r upon 3 into 1 plus root 3, and the last option is r upon 1 plus root 3, right? Okay, so we have to find out the value of x from charge q, where the electric field is 0. Now let's look at this question properly. Suppose I will extend this, okay? Okay, suppose I have this point as x, okay, near to this charge q. Then there is a possibility that the electric field will be 0, because near to this charge q, the electric field will, because of this charge, will be more, and because of this 3q charge will be lesser, because it is far away, right? Okay, what will happen here? The electric field due to this plus q and due to this plus 3q, can they ever cancel each other? The answer to that is no, because both of them are positive charges. So both of them will repel, right? Both of them will have the electric field directing in this direction. So they will never cancel. But in this case, if I say at a distance x, then there is a chance, okay? The electric field due to this q is in this direction, and the electric field due to this 3q is in this direction. Okay, now electric field due to this charge, let's call this as 1 charge and this as a 2 charge. The electric field E1 is equal to kq by x square. This will be in the right direction, and this will be balanced out by E2, which is k times 3q upon r minus x whole square, right? Correct, it will be in the left side. Let's equate both of these. So this is kq by x square is equal to k times 3q by r minus x whole square, right? So k gets cancelled, q and q gets cancelled. So we have 1 upon x square is equal to 3 upon r minus x whole square. If I take a square root, it will be 1 upon x is equal to plus minus root 3 upon r minus x, right? Either positive or negative will be the answer. Let's see. So if I take a positive line, 1 upon x is root 3 upon r minus x. So if I solve it, r minus x is equal to root 3x. Now if this goes here, r is equal to 1 plus root 3 times x. So x is r by 1 plus root 3. Okay, x is r by 1 plus root 3. And if it is a negative, what will be the answer? R minus x is equal to minus root 3 x, right? Okay, so this will be minus root 3 plus 1 into x is equal to r. But here minus root 3 is minus 1.7, right? So this is negative. So the x will be negative here. We will not take this solution. We will take this solution. Okay. So r upon 1 plus root 3. So the D option will be the correct one. Correct. So this is how you solve this question. JEE means, let's look at this question. We have a charge of 10 microcoulomb and another charge is there of 40 microcoulomb. We have to place it on this axis in such a way that the electric field at x equal to 2 centimeter is 0. The options are minus 4, plus 4, 8 and 6 centimeter. You can try yourself. I will wait for 1 second. Okay, so you can pause it and you can try this question. Okay, so let me try this question. Okay, now there is a charge which is 40 microcoulomb which we have to place, right? So that the net electric field is 0 at x equal to 2. Now, if I place the charge somewhere on the negative side, right, then the electric field will never be 0 because both of them are positive and both the electric fields will be in this direction. Okay, here also the same thing, but here I can place it somewhere at this particular point, 40 microcoulomb charge. I don't know what is that distance. So let me call this coordinate at which I am putting this as x0. Okay, as x0. We have to find out this value of x0 such that the electric field at this point is 0. Now the electric field due to 10 microcoulomb charge will be in this direction, right? What will be the value of that? It will be k into 10 microcoulomb by r square. So I will work in the centimeter only, right? K into 10 microcoulomb by 4. Okay. And due to the 40 microcoulomb charge, it will be in this direction. So this will be k into 40 microcoulomb divided by x0 minus 2 whole square. x0 minus 2 whole square. Now both of them are equal because we have to make the electric field is 0 at that point. Okay, so k and k will get cancelled. Microcoulomb, this will be 4, right? So you will see here this becomes 16 is equal to x0 minus 2 whole square. So x0 minus 2 is either plus 4 or x0 minus 2 is equal to minus 4, right? So from here x0 will become 6 centimeter and from here x0 will be minus 2 centimeter. We will not take the negative solution because we are already placing it here at positive. So the x0 is equal to 6 centimeter is the correct option. So the D option will be the correct. X0 is 6 centimeter. Okay. Yes.